Then let us move on
Plus,
to, yes,
what 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 if you have infinity on both sides?
what do you mean? You mean how do I write it?
Um, like both on the left and the right side is just infinity, positive and plus.
You mean
You're
how do
not
I
given
draw
a
it on a
value.
number line? How do I represent it on the number line or
Yeah.
interval notation? On a number line, it's just like this. That's how it is. So it
Oh,
doesn't have a beginning. It does not have an end. So it's the entire number line. In interval
okay.
notation, we do it the same way, round brackets, just like that. Okay. So if it's all the numbers between minus infinity and infinity, that means it is every single number that we have, which means it's your entire number line. Okay. Okay. Do you have another question? Okay. Then there are some rules that we follow when we are talking about number lines. Now the first one here, if I have A, B, and C, these are all real numbers. So they're elements of the set of real numbers. That means they are real numbers. If I have this, number one, I have A is less than B. Then it doesn't matter what the value of of C, whether C is positive or negative. If I were to add C on both sides of the inequality, then the inequality will still hold. Okay, so if I have this minus 2, this is less than 0, then I can pick C equal to 3. Now if I add C over there and I add it over there, this inequality will still hold. So here I have minus 2 plus 3, 0 plus 3. I have 1 is less than 3. So you can see that the inequality still holds. As long as what you do on one side of the inequality is the same as what you have done on the other side, then the inequality is still the less than. What you had on the left is still less than what you have on the right. Now you can also pick a C, which is a negative number, and then you can see that your answer will be exactly the same. So if I pick C is equal to minus 1, so my inequality was minus 2 is less than 0. So if I add minus 1 on both sides, I have minus 2 plus minus 1. This will still be less than 0 plus minus 1. So this is minus 3. This is less than negative 1. And you can see this is still true. I had the less than in my inequality and I still have less than. My inequality was facing to the right, and in the final step it is still facing to the right. Okay, so the second one we have is that if A is less than B, then A minus C is less than B minus C. So again over here, it doesn't matter whether your C is positive, negative, or 0. If you subtract C on both sides, the inequality does not change the direction that it is facing. Just like with an equation, if what you do on one side is the same as what you do on the other side, then your equation does not change. So what we have is this for an example. Let's say we have 5 is less than 10, and then I will take C equal to 3. Okay, so I'm going to subtract 3 on both sides. So I have 5 minus 3. This is less than 10 minus 3. So 5 minus 3, this is 2. 2 is definitely less than 7. So the inequality is still true. You can also pick C to be a negative number. So 5 minus negative 3. This will be less than 10 minus negative 3. 5 minus negative 3, this is 8. 10 minus negative 3, this is 13. You can see this is still true. So if you have an inequality, this also applies with less than or equal to. So here, if I have A is less than or equal to B, then A plus C is less than or equal to B plus C. And the same thing, A minus C is less than or equal to B minus C. So the inequality does not change the direction it's facing when you add a number or subtract a number on both sides. Then the third property of inequalities that we have is if A is less than B. And now this time when when C is positive, C is a positive number, then if you multiply A with C, the value is less than what you get if you multiply B with C. It doesn't matter whether A and B are positive or negative. What matters is the C that you have over there. So we can look at an example. Let's say I have negative 2. This is less than 4. And then I can take my C equal to 5. Now, very important that C must be positive. If C is not positive, this property does not hold. So what I have here, I can say minus 2 times 5. This will be less than 4 times 5 over there. So negative 2 times 5, this is minus 10. And then 4 times 5, this is 20. And here we know that minus 10 is less than 20. So we can see that our sign did not change direction. It continues to face in the same direction. And then the fourth property we have is now what happens when when C is a negative number. So we have this, A is less than B, and then C is negative. So when we multiply C on both sides, what will happen is that the inequality will change the direction that it is facing. So what you'll get is that A times C is greater than B times C. So we can look at the same example we did above here. So we have minus 2. This is less than 5. And then I pick C equal to negative 1. Now when I multiply negative 1 on both sides, I have negative 2 times negative 1, and then 5 times negative 1. This is 2, and here I have negative 5. Now here obviously I cannot write that because that is not correct. 2 is not less than negative 5. So my inequality must change the direction that it is facing. So you can see over here I had a less than inequality. Then when I multiply both sides by a negative number, the inequality changes direction. It is now a greater than. So this is also true if you have negative 2 is less than negative 1. We know that this is true. Then if I multiply by a negative number on both sides, so I have negative 2 times negative 2, and then negative 1 times negative 2. Here I have 4, and then here I have 2. Okay, so this is positive 2, and we know that 4 is greater than 2, so my inequality must change the direction in which it is facing. Okay. Then the next property we have is if a is a positive number, so that means a is greater than 0, then this means that 1 over a is also a positive number. So here if I have 1 over 3, this is a positive number, then this also means that 3 is a positive number. So this seems trivial. The reciprocal of a positive number is obviously a positive number. That is one of the properties that we use. Then the next one, now if A is positive and B is also positive, and we have A less than B, then this means that 1 over A is greater than 1 over B. So this is true that if you have two positive numbers and one is less than the other, if you take the reciprocals, then the inequality will change the direction that it faces in. For example, if I have half, this is less than 3 over 2. So half is less than 1.5. We know that is true. Then if I write the reciprocals of both of these numbers, the reciprocal of half is just 2. 2 over 1 is 2. And then the reciprocal of 3 over 2 is 2 over 3. Now here again, I cannot keep the inequality like that because 2 is definitely not less than 2 over 3. So it must change the direction. So taking the reciprocal on both sides means that your inequality changes direction. Now with these properties that we know about inequalities, we can solve some equations. Now with inequalities, when we are solving it, it's pretty much the same as with an equation. You want to isolate x on one side, and then after that you'll just represent your solution on the number line or in interval notation, depending on how you're asked to do it. So linear inequalities. So we have x plus 5. This is less than 2. So what this means is I'm looking for numbers that when I substitute them over here, the answer will be less than 2. So there isn't just one possible answer, there's an infinite number of solutions. So I want to work out what all those solutions are, or to describe what kind of number can I substitute over there so that my inequality holds. So just like with an equation, you would take everything else to one side. X must remain by itself on one side. So that is what I do. So just write it here. So it's x plus 5. This is less than 2. So to get rid of the 5, I must subtract 5 on both sides. Now when I subtract 5 on both sides, remember our second property of inequalities was that the direction that the sign faces does not change. So this is just x is less than negative 3. So it remains as a negative, as a less than symbol. So over there it is less than. When I subtract 5 on both sides, the inequality does not change. So the inequality sign changes direction if I multiply by a negative number on both sides, or I take the reciprocal on both sides. Otherwise, it must remain as it is. So now any number less than minus 3, when I substitute it into my equation over there, it will give me the desired solution. It will give me an answer that is less than 2. So we can always check. So you pick a number that is less than minus 3. So for example, minus 4. Minus 4 is less than 3. Then you substitute it. You say minus 4 plus 5. This is minus 1. It's 1, not minus 1. So this is equal to 1. And 1 is definitely less than 2. So this is correct. So you can pick any number that is less than minus 3. You will see that your solution, that it does satisfy the inequality. You can also check, pick a number that is bigger than minus 3. Let's say 0. If I try 0 there, I substitute it. I will have 0 plus 5. This is equal to 5. And 5 is not less than 2. So it does not satisfy. So you can see that when you pick numbers that are less than minus 3, it satisfies your inequalities, and numbers greater than minus 3 do not satisfy the inequality. Then you can represent this on your number line. Say this is your number line from minus infinity to infinity. We want numbers that are less than minus 3. So minus 3 is one endpoint, minus infinity is the other. We said we have an open circle on top of minus 3 because minus 3 is not included. And then we draw a line that goes all the way to negative infinity. Okay, and then in interval notation, our endpoints, minus infinity and minus 3. Minus 3, not included, it's an open circle. And then minus infinity is never included. So next to minus infinity, there is always a round bracket. We can look at another example. We have 2x minus 1. This is less than x plus 3. Okay, so here again, we collect all the terms with x on one side, all the terms without x on the other side. So I will start by subtracting x on both sides. So I have 2x minus x, and then I add 1 on both sides, and I have 3 plus 1. And very important, my inequality has not changed direction, because when I add or subtract anything, whether it's positive or negative, my inequality must remain the way it is facing. So it does not change based on adding or subtracting anything on either side. Then you simplify on the left hand side. You have 2x minus x. This is just equal to x. And then 3 plus 1, this is equal to 4. So your inequality is satisfied by values of x that are less than 4. So again, you can always substitute and check. So pick a value less than 4. Let's say you have 1. So on the left, you'll have 2 times 1 minus 1. This is 2. And then on the right, you have 1 plus 3. This is 4. And here you can see that 2 is less than 4. And then also try pick a number that is bigger than 4 and see does it satisfy your inequality or not. We have minus x over 3. This is less than 2x plus 1. So here again, the procedure is pretty much the same. All the terms with x on one side, everything else on the other side. Okay, so this one I didn't represent it. I should just say this goes from minus infinity to 4. So that is in interval notation. Okay, then this one again, I can subtract 2x on both sides. So minus x over 3 minus 2x. This is less than 1. And then these two, I combine them the way we always do. It's negative 1/3 minus 2. This is minus 7 over 3x. This is less than 1. Now I want to isolate x, so I will divide by negative 7 over 3 on both sides. And we said when we multiply or divide by a negative number on both sides, then your inequality changes direction. Because multiplication and division are the same thing. If I'm dividing by negative 7 over 3, that is the same as multiplying by negative 3 over 7. So here I can say divide by negative 7 over 3, divide by negative 7 over 3. Then I'll be left with x, but then my inequality changes the direction that it is facing, and then I have negative 3 over 7. So very important when you multiply or divide by a negative number on both sides, your inequality must change direction. And with an inequality, just like an equation, what you do on one side, you must do on the other side to preserve the inequality. And then you can represent this on your number line. This says that x is greater than negative 3 over 7. So if I want numbers that are greater than negative 3 over 7, I must look on the right of negative 3 over 7. So here I have an open circle, and numbers that are greater than negative 3 over 7 are on the right. Then in interval notation, the endpoints are negative 3 over 7 and infinity. And then I have a round bracket with both of them because negative 3 over 7 is not included and infinity is never included. Then you can also work out inequalities where you have a double inequality. So this, for example, x plus 4 less than 5. Now with these ones, what you want to do is isolate x in the middle. So if what you have there is some expression of x, what you should do is make sure you have x alone in the middle. So this one is very simple to do because I will just have to subtract 4, and you should think of this as 3 equations. So you subtract 4 from each of them. So you'll say 2 minus 4 is less than x. This is less than 5 minus 4. So you subtract 4 there, subtract 4 over there, and subtract 4 over there. And remember, when we are adding or subtracting numbers on an inequality, the sign does not change direction. That is why I still have less than over here. That is just less than. It does not change direction. Then I can simplify this. 2 minus 4, this is negative 2. And then 5 minus 4, this is 1. Okay, so when I represent this on the number line, my endpoints are negative 2 and 1. I have open circles on top of both of them because these are strictly less than. Then I connect them with a solid line. And in interval notation, I would write my two endpoints and then open round brackets next to each of them. And then you can try it, check your solution. If you pick any number in this interval that is between minus 2 and 1, substitute it over there. When you add it to 4, the answer will always be between 2 and 5. So if you pick 0, you put 0 over there, you'll have 0 plus 4, which is 4, and 4 is between 2 and 5. If you pick negative a half, negative a half plus 4 is 3.5. 3.5 is between 2 and 5. And then try picking another number that is outside of this interval. Let's say 10. You say, what is that? 10 plus 4 is 14, and 14 is not between 2 and 5. So obviously doesn't satisfy the inequality. And then on the other side, let's say 0. Sorry, not 0. Minus 5. If I put minus 5 over there, minus 5 plus 4 is 1. 1 is not between 2 and 5. Okay, so this tells you that my inequality is correct. That is the correct interval for my solution. So we have minus 2. This is less than or equal to minus 3k minus 1 less than minus 5. So again, over here, what we want to do is to isolate the k in the middle. So we start by adding 1 on both sides, on all three sides. So this is minus 2 plus 1. Here I will have minus 3k, and then I have 5 plus 1. Okay, so you add 1 to all three parts of your inequality. Then here you have minus 1. This is less than or equal to minus 3k. This is less than or equal to 6. Now this inequality, you can rewrite it as two inequalities. And when you do that, what you will have is this. We have minus 1 is less than or equal to minus 3k. So that's this part over here. And also minus 3k is less than or equal to minus 6, which is this part over here. So I'm rewriting my inequality as two different inequalities. And here, the end, that is important. That will show me that minus 3k is between minus 1 and 3. So what you can do is you can solve each of them and then combine your solution. So I have minus 1, this is less than or equal to minus 3k. I want to isolate k, so I can divide by negative 3 on both sides. Now when I divide by negative 3, so here I have divide by negative 3, divide by negative 3. The rules of inequality say dividing by negative 3 changes the direction of the inequality. So here I will have 1, and then my inequality changes, and then I have k. So this is the first one over here. And then the second inequality I had was this one over here.
Miss,
Yes.
isn't the answer supposed to be 1 over 3?
Yes, 1 over 3. That's correct. The second inequality was minus 3k. This is less than or equal to 6. So again, you'll divide by negative 3, divide by negative 3, and then what you'll have here is k. Then your inequality changes direction, and then this time you have negative 2. So the solution is that k must be, you must have this 1 over 3 is greater than or equal to k, and k is greater than or equal to minus 2. So that is your solution, and you can represent this on your number line. On your number line, you have your endpoints. You have negative 2, and then you have 1 over 3. Now we said k must be greater than negative 2, so it will be on the right of negative 2, so somewhere this side. And it must also be on the left hand side of 1 over 3, because it is less than 1 over 3, so it's this side. So if I look at my number line, the only region that is on the right of negative 2 as well as on the left of 1/3 is the region over here. So I have shaded, shaded, and then connected. So this is the region that satisfies both of this. If I pick any number in here, that number is greater than negative 2, and it is also less than 1/3. And in interval notation, this is minus 2 square bracket because it is included the less than or equal to over there. So I have minus 2 and then 1 over 3, and that is my solution. Okay, so there are more questions that you can try in the notes. It's good to practice, especially with these double inequalities. The key idea is just to isolate your x in the middle, and then if you have to divide by a negative number on both sides, break up your inequality instead of writing it like this. So what I had was this minus 1 is less than or equal to minus 3k. This is less than or equal to 6. Then if I were to divide by negative 3 the way it is, what I have is 1 over 3. The sign changes direction. I have k, and then this changes direction to minus 2. This is wrong because you are saying that k is greater than, sorry, k is less than a third, and it is greater than, or maybe I shouldn't say it's wrong, it's just, it's not a good way of writing it. We always want our smaller numbers to be on the left and our bigger numbers to be on the right. So it's not good practice. We don't write it like that. Not that it's wrong. Okay, so that's how you would do that one, but try and break it up and then combine it again. It looks better when you have smaller numbers on the left compared to when you have them on the right. Just a few things on e-learning today. You'll notice that the tutorial test 9 is out, except for this week there is a requirement, a prerequisite in order for you to do tutorial test number 9. That prerequisite is that you need to submit your practice test. This practice test thing was a suggestion from you guys that you wanted this, and I was so surprised when very few people actually submitted or even took part. I had so many questions. Is this for marks? Oh, it's not for marks. I don't have to do it. And very few people actually did it, which is very disappointing because this is something that you asked for. So I have made it a requirement. This is actually for marks because if you do not submit your practice test, you will not be able to do tutorial test number 9. That means you will get a 0 in tutorial test number 9. I see that is the only way that people do things. So please go and submit it. Even if you submitted it on Saturday, then it's very easy for you because you will just take that same copy and you submit it. I also didn't like that some people submitted the test paper back. They did not try the test. They did not scan anything, just submitted the test. So this one I will be checking. You do not submit your practice test, you will not do the tutorial test. So if you're willing to get a 0 this week, that is up to you. You must do the practice test. If you have not done it, go and do it and submit it. Because on Saturday, I do not want anybody telling me I don't know where to go. I don't know how to submit. You only have 2 hours and that is all you will get. Do you have any questions? I think it's
Yes, ma'am.
clear. Yes. Is it clear? Or you have a question?
Yeah.
Yes, please
If
ask
we are
me.
dividing with a positive, do we have to change the sign?
No.
Okay.
Yes. Any questions on the practice test, this week's tutorial test? Are those ones clear? If you do not do the practice test, that means you do not submit one scanned PDF document, you will not be able to do tutorial test number 9. I saw last week people were struggling. They couldn't open tutorial test 8, and that was because you did not read test 2 information. It surprises me that you see something on e-learning, something new comes up, it says test 2 information, and then you just ignore it. Okay, this is information for you guys. This test that is coming on Saturday is 33% of your final grade. Failing this will put you in a very bad situation. So please put in the effort that this test carries. Is it clear? Do we have questions? Are we fine? You can tell me you're fine, then I know I'm not talking to myself. Please.
I think we are fine.
Okay. I hope
Ma'am,
so. Yes.
ma'am,
Yes.
ma'am, how do you put your test in one PDF only? How do you send
I
it as one document only?
I think
That
I
is what
made a
I'm struggling with.
video. I made a video of that. It is also there on e-learning. I posted it on the group. It is also here on Teams. I showed you how to do that because I submitted it on my phone. So somebody who doesn't have a laptop can absolutely do this. And I used Adobe Scan. It puts everything as a single document for you.
Okay, okay,
Yes.
ma'am.
So please watch that video.
Okay, ma'am.
All right.
Mm,
Okay, if we are all fine, please go and submit. Tell your friends who are not here that they need to submit. This is a requirement for the test. Another thing, this tutorial test does not close on Sunday. It closes on Saturday before the test. So some of you, maybe you're thinking, I won't submit. I'll just wait for the test. I'll do it after the test. No, the tutorial test closes before the test. So that means if we write the test and you did not submit the practice test, automatically you get a 0 in the tutorial test. So you must go and do it. So please go and do it. Do not call me on Sunday and say, Miss, why is the tutorial test closed? It is closing early this week because I see I need to force you guys to submit. So go and submit. Okay, and if you submit the question paper back to me again, you will not write that tutorial test. You must submit the practice test and not biology test. I saw people submitting biology scans. Uh-uh, it's not biology, it's SAT. Okay, so I will see you guys on Tuesday. That's tomorrow. I'll see you guys tomorrow. Have a good day. Go and
Have a
submit.
good day too.